Hi, good afternoon or good morning, depending on where you are in which time zone. So I'm going to jump straight into it. This is the ZP Developer Zone. Now it says here on the 7th of April, but I realize that we've gone live early. It's just because we normally do this on a Sunday afternoon, at least UK time, but we're going to do it early on a Saturday evening. Just lots and lots of things going on, so we need to go early. I want to be efficient as per normal, so I've got about 5 questions that I want to get through. Some of them are quite straightforward, some are a little bit more technical. Question number 1 is about a low-cost option to microneedle technology. So in particular, there's 2 questions wrapped into one here. One group are interested in microneedle technology for glucose monitoring, and another group is interested in microneedle technology for lactate monitoring. And I'm going to simply say it now, and I'll say it again, that at ZP, in fact, I have them in a cupboard just here. We have 2 versions of microneedles. One of the microneedle technologies is a microneedle technology that's protected by 50 patents. It's our, how can I put it? It's really our premier product. And in fact, yeah, so it's something that I'll have a little image of. And then we do put some microneedle technology just generally available on the website, but really don't hold that as our most premier product. The most premier product is something that we actually only use with well-funded clients. I mean, when we talk about microneedle technology, it's probably worth just mentioning that I just saw in the last 24 hours at BioLink, I made a public statement that they've just raised about 50 million US dollars. So I think the timeline on BioLink are doing a CGM, continuous glucose monitoring using microneedles. They were around for 7 years. Then they raised about $100 million about 2021-ish. And they've just raised just short of 50 million again. I bring it up because obviously if you're really getting into microneedle technology for CGM, if it's continuous glucose monitoring or continuous lactate monitoring, they're both equally as challenging, and that's the kind of numbers that you have to be raising in order to be in the diabetes market. I can understand that might be different in wellness market or sports markets, but just FYI. Anyway, we'll get to question 1 shortly. Question number 2, somebody is making a phosphate sensor. They'd like to compare against our phosphate sensor, so I'll just make a quick comment on that. Somebody else is very interested in measuring bacteria. You can measure bacteria through ATP, adenosine triphosphate. It's quite a standard way of doing it, so I will make a quick comment on that. Question number 4, I've been supporting this person for a little while. They're using one of our hyper value screen printed electrodes. I know it's my opinion, best electrodes in the world. Why? Because ZP uses them all the time. We make sure the quality is really good. And I want to just make a few comments on connectors for that to help that client. And somebody else is actually using something that we used to do a lot of, which is, we call it the 101s. These are, most of our screen printed electrodes today are actually 7 millimeters wide. Why? Because we can basically manufacture them at a lower cost, which we actually pass on to clients. But we still have some sort of 10 millimeter clients out there as well. So I just make a comment on flow adapters for 10 millimeter electrodes as well. That said, I know I'm speaking fast, but it's just to get through things quickly. We do have some webinars coming up. ZP is really all about getting people to market. So I think there's 2 ways we really kind of focus these days: getting people to market and probably supporting academic research. For us, see, those 2 things are actually quite connected, because academic research brings you to technology readiness level 3, and then it's kind of, startups in industry, bring them from 3 to like 9. But that said, we do have a webinar on the 23rd of April, 1 in the morning, 1 in the afternoon, and these are just really to give you a sense of what Sense It All is. And to be honest with you, we can get most people to market if they've got enough funding in about 2 years with the Sense It All platform. And then I do get, with academia, I want to make sure that I give people the best chance of, doing good research. And I think one of the biggest problems that I see in academic research is actually repeatability of screen printed electrodes. So we will have a webinar on the 24th of April, 1 in the morning, 1 in the afternoon. These are just repeats. We do repeats just so that people can actually join from whatever time zone they're actually in. So any links that are popping up, I'll put them underneath the video anyway. Question number 1, I put microneedles for lactate here, but I should also put microneedles / for glucose as well, because I'm mixing up 2 questions here. we do have a technology that's not available on the website. It's for microneedle technology. It's protected by 50 patents. It's actually had over 20 million US dollars invested in it, which is nothing when we talk about the investment so far made by a BioLink. As I say, that's easily in excess of 150 million US dollars today. Just out of interest, Dexcom, who've also done a transdermal CGM sensor, they're number 2 in terms of probably market penetration after Abbott. I heard the other day that they actually spent 500 million US dollars before, on their journey to being who they are today. So FYI, it's quite hard to make a robust enough glucose sensor that can be used in diabetics. That said, at ZP we do have, if somebody wants to make a low-cost CGM or a low-cost lactate sensor and just do a proof of principle, we do have microneedles. One of the people who I'm responding to today was concerned that the microneedles we have are gold. Do not be concerned. If you're using an oxidase enzyme, be it glucose oxidase or lactate oxidase, that gold works. In fact, I should have really clicked on. The microneedles. We have the electronics here, and there's also the activation solution, and there's also the glucose activation is here as well, and also the test solutions. I should have put an arrow on electronics as well. For me, the things that you need if you want to make if you have a small budget and you want to make a glucose microneedle technology, the microneedles are here, the electronics are here, the activation solution is here, and the glucose activation is here, and the test solution is here. If you want to do lactate, it's also the same, very similar button. So here's the link here. But I have sent this link already out to the lactate team. I think they were concerned about the oxidation hydroperoxide on gold. And I was always under that kind of belief as well that you couldn't oxidize hydroperoxide on gold as well. And then I just sort of mentioned it once to somebody, said, well, "What are you, daft?" I was like, and then I looked into it in a bit. I was like, "Oh, okay, yeah." And so I did actually just confirm with a really senior engineer that I have as well. I was like, make sure I wasn't being crazy, and he said, "Yeah, no, you can, absolutely." He said, so you can oxidize hydroperoxide on gold. So that is your solution. Here are the microneedles. Now I've just put a quick picture of myself because really, if you're a commercial organization and you want to seriously make a microneedle, either lactate or glucose technology, it's probably super wise to actually engage ZP in a private program, not just components off the website. Components off the website will get you to kind of a proof of principle, a benchtop system, but they're not there to make you a wearable technology that you can slap on your arm and off you go. Question number 2, somebody is developing a phosphate sensor, interested in comparing it against our phosphate sensor. Our phosphate sensors are available in packs of 100 on the website. And the phosphate sensor will actually work with our SensiAll platform. So basically, this is the good thing about SensiAll platform. It's really a developer's platform for people who think that measuring phosphate is useful for a particular client base. It's a really small amount for actually going from 0 to something very substantially, the SensiAll platform. It doesn't exclude you from the science because actually all the raw signals go to the cloud anyway. And it's actually robust enough that you can put it in the hands of real people. So if you really want to make a impact, at ZP, we kind of say that, you need to get technology onto the market in 2 years or less. And that's to a startup. And how do you do that? You have to skip a lot of the technology barriers. And that's why we make the SensiAll platform. I would say the same to the person I'm going to address with the ATP, adenosine triphosphate. Do come to our webinar on the 23rd of April. And if you're watching this later, we do these webinars every month. So the link that you see pop up here, we'll just refresh it with the latest webinar. So what am I saying here? I am saying that the phosphate sensors are available on the web store. They do actually work with our SensiAll platform. And if you're a kind of company that's interested in water quality or soil quality or soil nutrition, then that's a good platform for you. Question number 3 is about ATP, adenosine triphosphate. Little fact or quick fact, ATP is used a lot. People swab down surfaces, they get a color change that tells them that there's ATP there. It's not quantitative. It's not quantitative, it's only qualitative. So ZP, we do actually make our ATP technology also available on our Sensi-All platform as well. Again, if there's a link, I'll put the link underneath the video as well. Question number 4 is a bit more of a longer one now. So question number 4, at ZP, we make a whole bunch of screen printed electrodes. These are the ones that I really kind of promote and support. Why? Because we make them in the highest numbers of volumes. And in this particular case, somebody's got a hyper value carbon electrode office. If you're interested in our screen printed electrodes, here's the link here. They've got a connector office, which I'm delighted. The connector is designed to take the 7mm screen printed electrode from us, and then there's some receptacles on the back of it which are 2mm, and that's designed because they've got a particular potentiostat that has banana plugs that have 2mm connectors. I really come across the companies that only manufacturers of potentiostats really only use 2mm and 4mm diameter. So just check out which one you have. The reason we made these connectors, in fact, is because we had a client who was having some problems. There was nothing wrong with the connector they had. It just didn't work well with our particular screen printed electrodes. So be careful if you're using ZP screen printed electrodes. I know I'm not using our connector. You could end up with some bad results, and it's just because the connector is not making a good enough connection with the screen printed electrodes. Otherwise, the screen printed electrodes are really kind of excellent. So the electrode that the screen printed electrode that the connector they have is designed for these 2mm banana plugs. This is the instrument that they have. So we've had this kind of long conversation, and we know what they've got. But the problem that they have is it's shielding too much of the screen printed electrode. They have a very particular need, let's say. They want a bit more exposed screen printed electrode. So they could actually, you know, I don't want to tell them to start cutting away bits of plastic, because if they overcut it, they'll damage it. But it's their call if they want to do that. I think we suggested, having understood what they've got, that they actually went for one of our cables, and they said, well, can you send us some images of what those cables look like with the screen printed electrodes in there, which we've done. And then they were kind of asking us, well, how much of the screen printed electrode is now exposed? So we're now in standard connector. I have a suspicion that we're kind of covering up about half of the screen printed electrodes. But when we go for the cable, that kind of becomes more like covering up about 2/3 the electrode. So I did a quick, I did a bit of measuring today, and I've got a suspicion that you will have exposed about 12mm of the screen printed electrode. You wouldn't really want to get any closer, because you're getting a bit closer to the connection there. So the quick answer to your question is, I think if you go for the LEMO 5-pin connector for the 7mm screen printed electrode, it'll give you about 12mm of exposure. Question number 5, this particular person has our 7mm screen printed electrode, which I'm super happy about, because that's really the one we're going to kind of go forward with. But they do still have a liking for some of our 101s. I can't quite remember what instrument they have. So if you have an instrument from ZP or from PalmSense that does not have EIS, electrochemical impedance spectroscopy, then you need the LEMO 4-pin. But if you have EIS capability on that potentiostat, which I think you possibly do have actually, then you will need the 5-pin connector. And because you are on the 101s or the 10mm, you'll need that. So they have a flow connector office. The flow connector they have is set up for the 7mm, which is great. It works fine. But actually they also have some 101s office as well, and that needs a different size flow adapter, which unfortunately means I'm pretty sure that you're actually got EIS capability, so you need to click this button, and you have a 101, so click this button, and I'll put the link to that as well. So I know I spoke rather fast. I mean, these were more kind of detailed questions. There wasn't a lot of science this week, but I think the science that we did put out there this week is we do have some microneedle technology available on the web store for people who are interested in making continuous lactate or glucose. You really have to engage with ZP in a very deep way to get hold of the technology, which has had about 20 million US investment in it, and it's got 50 patents behind it. But we do have some other microneedles available on the web store, and I've had it confirmed by one of our senior guys. I knew anyway, but I just got it confirmed that the gold is actually will oxidize hydroperoxide. Phosphate sensor, the sensors are available on the web store. If you want to buy them and compare them against yours, I saw that you were using semiconductor fabrication for that, so I thought that was kind of interesting. ATP, adenosine triphosphate. Yes, we do have the sensors. Yes, you can use ATP to measure bacteria. It's quite commonly done. The reason you might want to use our platform is because it allows you to quantify the ATP, whereas most swab tests just qualify it. For the connector, I think that ZP connector or ZP cable will give you about 12 millimeters of exposure of that screen printed electrode. I hope that helps you. And then lastly, I think you're on a Anapot EIS, so you need a LEMO 5-pin connector, and you've got 10 millimeters, so choose the 101 button. I know I spoke rather fast today. Today, I must admit, there was less science. It was more kind of clarifying things for people. I think the only real science there was, it may be a bit of an eye-opener to people that you can actually use gold electrodes to oxidize hydroperoxide. So that means you can use it with a whole bunch of oxidase enzymes. So I want to say thank you very much. If you've got any questions, we do have a webinar on Thursday, so just reach out to us. We tend to do these on Thursdays and Sundays because I don't like to leave too big a gap from people asking a question to us answering a question. But if you've got any questions, don't hesitate to reach out to us. Okay, thanks very much.